Hi, Algebra 1 students. Welcome back. Last time we talked about section 10.5 extension, which was graphing parabolas in vertex form. And for this video, we're going to be talking about comparing functions. So we're going to be really focusing on, different properties that distinguish a specific type of function. So please go ahead and take a moment to get a title on the top of your notes, 10.8. Comparing models. And we're going to go ahead and start discussing the three types of functions that we're going to focus on for this lesson. So we're going to be looking at specifically linear, exponential, and quadratic functions. So let's talk about a linear function. Now we've been talking about linear functions all year. Now the word linear basically just means line. So when you see a linear function on a graph, it's going to look like a line. Okay? Now we say that the equation for a line is y is equal to mx plus b, right? That is slope-intercept form. For an exponential function, well, we can have growth and we can also have decay. But for growth, in general, the graph is going to start off small and then it's going to get what we say exponentially large. So it's going to kind of start off as a straight line and then kind of curve up and go up to the sky. So that's going to be growth. And the equation for growth, y is equal to a times b to the x power, and b has to be a number greater than 1. So b is greater than 1. Now for decay, when we see decay, that means that we're starting off large and we're getting small, exponentially small. So for decay, we say then that b is less than 1. It's still following the same model, y equals a b to the x power, but b is less than 1, which is making that function decrease over time. And then for a quadratic, we know that quadratics, when you graph them, they make parabolas. We also just call them a U-shape. So when you see a quadratic function, it's always going to look like this U-shape that's got symmetry. It's got symmetry. The axis of symmetry is going to go straight down the middle of that parabola. And the equation is going to be y equals ax squared plus bx plus c. All right? Now there's different forms of quadratics. In general, you need to see the x squared in your quadratic, and that's how you will know it's going to be a U-shape. So what we're going to do here is we're going to graph a couple of functions given some ordered pairs, and we're going to just look at the shape of the graph to determine what type of function we have. So let's start with example 1. We're going to plot the points that we have. So let's start with -2, 1/9. So we're just barely above the x-axis here. And then -1, 1/3. We're not too much farther above than 1/9. 0, 1, and 1/3. And then lastly, we have 2, 9. It's going to be way up here, 2, 9. Okay, so I'm going to connect these points, and you're going to see that exponential shape. So it starts off kind of as a straight line, and then it curves up and goes to the sky. So that is an exponential function. Okay, let's look at number 2. So let's see, -2, +3, -1, 0, 0, -1, 1, 0, and 2, +3. If I connect these points, that makes my U-shape. We also call that a parabola. So number 2 is a quadratic function. Okay, so plotting points, looking at the shape comparing it to what we know a linear, exponential, and quadratic function look like, and then identifying the type of function. So what I would like you to do is I would like you to try identifying a function based on the shape of its graph. I want you to graph each set of ordered pairs in 1 and 2 on 2 different graphs and look at the shape of it and compare it to what you know a linear, exponential, and quadratic function look like, and then see if you can determine the type of function. I want you to go ahead and pause the video. When you're done and you're ready to go over your answers, go ahead and resume playing and we'll talk about the correct answers. Okay, so number 1 is a linear function. When you plotted all 5 points, they fall nicely in a straight line that's slanting down in the negative direction. It's decreasing, so it'd be a linear function and its slope would be negative. Number 2, when you plot those points and connect the dots, they fall in that U shape or a parabola, which makes it a quadratic function. Okay? So graphing is, it's a lot of work to plot a bunch of points to tell, what type of a function you are dealing with. So there's other tricks that we can use just by looking at our outputs, our y values, we can determine what type of function we have. So what we're going to do here is without graphing and just observing the points in a table, we're going to figure out what type of function we have. So let's start with number 1. If we look at our outputs, and we're looking for a pattern in the outputs. So if you look at the difference between -7 and -4, we're increasing by 3. In -4 to -1, we're increasing by 3. -1 to 2, increasing by 3. And then 2 to 5, increasing by 3. So we're increasing by the same amount, a constant amount each time. So that represents a linear function. And remember that a linear function, that increase is going to be our slope. That's going to be our rate of change. So that would be m. How much are we changing each time? We're changing by 3. We're increasing by 3, so a positive 3. On number 2, just looking at the outputs, what is the pattern? How can I get my y values given a previous y value? So if you look at 1/4, I could double that or times it by 2 to get a half. Or 1/2 times 2 gives me 1. Or 1 times 2 gives me 2. And 2 times 2 gives me 4. So instead of adding, this time we're multiplying, and so we're getting larger by multiples of 2, which means we have an exponential function. And our exponential functions look like y equals ab to the x power. And we say that our rate of change, we're multiplying by 2, so b would be equal to 2. Okay, this would be exponential growth because b is greater than 1. Now number 3 is kind of interesting. We decrease from 1 to -2, and then we decrease from -2 to -3, but then we increase and increase. So instead, let's look at this kind of interesting pattern. The outside numbers are the same. And then these kind of middle numbers, -2 and -2, those are the same. And then right here in the middle, we have -3. So you see that U shape in the pattern in the table. You see symmetry. So number 3 is going to be a quadratic function. So it's going to be our y equals ax squared plus bx plus c. And in fact, this middle point right here, that is going to be our vertex. That's going to be our vertex. okay? Because remember, the axis of symmetry goes through the vertex in a parabola. All right, so what I want you to do is I want you to see if you can figure out, just by looking at the pattern in the y values, what type of function you have. So I want you to do 1 and 2 without plotting the points on a graph, just looking at the pattern, see if you can figure out the type of function. I want you to go ahead and pause the video. When you're ready to go over your answer, you can resume playing and we'll talk about the answer. Okay, so number 1, if you look at the pattern in our y values, if we multiply each y value by 4, it's going to give us our next y value. So 1/16 times 4 is 1/4, 1/4 times 4 is 1, 1 times 4 is 4, and 4 times 4 is 16. So we would say that number 1 is an exponential function. For 2, we are decreasing by 5 each time. So you take 5 away from the y value, it gives you your next y value. So number 2, since we're decreasing at a constant rate, we're subtracting the same amount each time, we would say it's a linear function. Okay? So you should be all ready to go to start reviewing for your test. I appreciate you watching the video today, and I hope that you have a lovely day. We'll see you next time.